Hello. Today we'll be solving this expression, the limit as x approaches infinity of 3 plus 2x all to the power of 1 over x. Whenever we're solving a limit problem, the first step I usually take is to try plugging in the thing that the limit is approaching in order to see what the expression does near that value. And so when we plug infinity in for x in this case, we get 3 plus 2 times infinity all to the power of 1 over infinity. Okay, now 2 times infinity is infinity and 3 plus infinity is still infinity. So inside of this set of parentheses we have infinity. And that's being raised to the power of 1 over infinity, which we know from the textbook is equal to 0. And so here we have infinity to the power of 0. And this is an indeterminate case because we don't know what the exact value of this expression is. Is it infinity? Is it 1 because anything to the 0 power is 1, or is it something else? This is an indeterminate case. And so our strategy to solve it will be to convert this indeterminate form into one of the two indeterminate cases that we can use L'Hopital's rule on, either infinity over infinity or 0 over 0. So that'll be our approach to this problem. The next step I usually take, whenever I have a limit with an x in the exponent, I like to take this limit and set it equal to some variable, usually y. So I'll say y is equal to the limit as x approaches infinity of 3 plus 2x all to the power of 1 over x. This is useful for two reasons. First of all, it helps us keep track of the value that we're looking for. In the end, we're going to want y equals. We're going to want to solve for y. The other reason this is useful is that it allows us now to do operations on both sides of the equal sign, which we're going to take advantage of now. Our next step will be to take the natural log of both sides. So we'll get the natural log of y is equal to the natural log of the limit as x approaches infinity of 3 plus 2x all to the power of 1 over x. Perfect. Okay, now we want to try to rearrange this right-hand side into an indeterminate case situation. So the first thing that we can do is we can bring this natural log inside of the limit. So we'll preserve the natural log of y on the left-hand side, and we'll have the limit as x approaches infinity of the natural log of 3 plus 2x all to the power, 3 plus 2x to the power of 1 over x, just like that. Okay, and this is helpful because one of the properties of natural logarithms is that if we have the natural log of something to an exponent, we can bring that exponent out to the front. So I can write 1 over x here times the natural log of this, and then I can erase that 1 over x. So I'll erase the 1 over x, and then I'll also erase this bracket that I've placed in the middle. Perfect. So now we have the limit as x approaches infinity of 1 over x times the natural log of 3 plus 2x. Okay, the next step will be to convert this into one fraction. So we can write that as the limit as x approaches infinity of the natural log of 3 plus 2x all over x. Perfect. Now our next step will be to try plugging infinity into this expression again in order to see if we have an indeterminate case yet. So let's do that. When we put infinity in here, we get 2 times infinity plus 3 inside of the natural log. So we get the natural log of infinity over infinity. And now, the natural log of infinity, if you remember the natural log curve, it looks kind of like this. The natural log of infinity is equal to infinity. And so we have infinity over infinity. We've got a L'Hopital's rule type indeterminate form, which means that we can use L'Hopital's rule now on this expression here, which is awesome. Okay, so I'll write L'Hopital's rule out in the next step. We've still got the natural log of y, and that is equal to the limit as x approaches infinity of the natural log of 3 plus 2x all over x. And now we're going to take L'Hopital's rule here. So we'll take the derivative of the top and of the bottom separately. I'm going to write that this expression is equal to, and above the equal sign I'm going to write an h to denote that we're using L'Hopital rule to move from this step to the following one. And now I'll continue to write the limit as x approaches infinity. And I'll take the derivative of the top, which is 1 over 3 plus 2x times the derivative of the inside, 3 plus 2x, the derivative of that is 2. Remember the chain rule. Over the derivative of x on the bottom, which is just 1. And now we can simplify this expression down to the limit as x approaches infinity. We can multiply this 2. This is the same thing as 2 over 1, so we can combine these two fractions and make it 2 over 3 plus 2x times 1 is just 3 plus 2x. And this is all still over 1 from here, but I'll go ahead and not write that divided by 1. Okay, now plugging in the infinity one last time. If we try plugging in infinity into this expression, we get 2 over 2 times infinity is infinity, and infinity plus 3 is infinity. So 2 divided by infinity, which is equal to 0, because any constant divided by infinity in limit is 0. Okay, great. So now we know that the natural log of y is equal to 0. But remember that we're not looking for the natural log of y, we're looking for y. And so we'll need to do one last thing in order to isolate y. Right now we have the natural log of y is equal to 0. And so in order to get rid of the natural log, we can take both sides of this equal sign and make them exponents of e. E to the natural log of y equals e to the 0. E to the natural log of y leaves y, and e to the 0, that's equal to 1. So we get that y is equal to 1. And so we conclude that the limit as x approaches infinity of 3 plus 2x to the power of 1 over x is equal to 1.